Hey folks, we at Legrand have been working very closely with the manufacturers of all the very small form factor connectors along with the tester manufacturers to come up with different methods of testing. Until they had the adapters that accepted the very small form factor connectors, we had the 3-jumper modified reference. We still have that. There's a video on that you can search out and you'll be able to do that 3-jumper modified. However, for the testers that have the adapters for the very small form factor connectors, we recommend the 1-jumper reference along with the TIA standard. Today we're going to talk about the very special cords that are necessary for that 1-jumper reference, and we'll go ahead and we'll show you how to set that 1-jumper reference up. First and foremost, you want to make sure that you're working with products that are meant for fiber optics for cleaning them. 90% of your problems with referencing, 90% of your problems with testing are going to come from contamination, and working with the products, again, that are meant to clean fiber optics, like an OptiPop, like a One-Click, or lint-free wipes, 99% IPA alcohol. Those are the types of cleaners that you want to make sure that you're using. Also, in addition to proper cleaning, it's not a bad idea to use a scope to check the end faces. You want to make sure that not only are they clean, you want to make sure that they're free of defects, no cracks, no chips, no pitting. You got to remember on single mode fiber that core sizes are between 8 and 9 micron. That's much smaller than even just a human hair. So working clean is going to be your single most important piece. So this is a close-up of the MDC connector made by US Connect. There's also an SN made by Senko. These are 2 ferrule connectors. You can see that it's 2 ferrules within one body. The unique feature of the very small form factor connectors is that you can switch polarity. On the MDC, you switch polarity by simply pulling the boot back, turning it over, and sliding it forward. Now you'll notice that the MDC writing is upside down and that the triangle is on the bottom relative to the latch, and on the latch side there's nothing. This is how we determine one polarity from another on the MDC connectors. As I mentioned, Senko makes a VSFF connector as well. This is called the SN connector. The SN Easy Flip also has the ability to change the polarity. To do so, you simply remove the dust cap, twist the boot, pull the boot back, and then you can remove the shroud. Then you'll notice on the shroud, one side is bigger, another side is smaller but keyed offset. Then on the body of the connector, you have grooves and then smooth. Those are the indicators to let you know that you've actually changed the polarity. Now, when I first started, the big side was on top, so I'm going to turn it over so that the keyed side is up. Slide the shroud back on. Slide the boot up. Give it a twist. I can put my dust cover back on. And that's the process for reversing the polarity on the SN. The testers still have a transmit and a receive in 2 very different ports, so we're not able to have a 2-fiber connector. However, the test that we're conducting is on fiber that's built into a 2-fiber connector like this. Therefore, we're going to have a patch cord that has 2 fibers that breaks out to 2 individual connectors. On this particular unit, the transmit is an SC, so this SC connector will plug into our transmit, and the MDC adapter is looking for input on the fiber nearest the latch. So if I take this dust cap off, the fiber that's on the top nearest this latch has the fiber that's terminated from the other connector. So to take the explanation of the cord just one step further so you completely understand it, I want to use a VFL. You notice that this cord is connected to a VFL and I have it on the top ferrule relative to the latch. I'm going to go ahead and I'm going to remove my dust cap and I'm going to plug it into an MDC adapter. Now on this connector, the triangle, or the MDC writing is up and then the triangle is up relative to the latch. When I plug that in, you can see that we get light on the SC connector. The SC connector is going to be plugged into our transmit port on our tester. Now when I take this out and I reverse the polarity so that the MDC writing is upside down and the triangle is down relative to the latch, I plug that in, and now we can see that the light is on the MDC that's going to be plugged into our receive port. So now we're going to go into the actual referencing process. I'm going to show you the process on a Viavi tester. However, this process will apply to any manufacturer that has a very small form factor input connectors. If your tester manufacturer doesn't have those, then we have to, again, use that modified 3-jumper reference. What we'll need to do this is very simple. We need our testers, both local and remote. We need 2 of the Y-style MDC to MDC and SC, and then we need an MDC to MDC bulkhead. And now we're ready to talk about the actual referencing process. I'm going to show you the referencing process on this Viavi OLTS 85P. However, it will apply to every manufacturer's tester that's out there, so long as they have the very small form factor adapter for what you're working on. Again, this is the MDC adapter, so we're going to be working with MDC connectors. If you're working with one of the other very small form factors, you'll need an adapter for that. We're going to start off by directly connecting the units just like you would in any other single jumper reference. Most of what we're going to do now is going to look very familiar to you if you know how to do the single jumper reference with LCs. So I'm going to remove the SC, I'm going to clean it, always cleaning every step of the way, and I'm going to plug that in. I'm going to take all of the twists out of this cable. It's very important when you're setting the initial reference that the cable is as straight as possible. Any bends or kinks are going to introduce a loss to the reference that's going to give us an optimistic result down the road. Now I'm going to go ahead and connect the other connector, the other SC, into the transmit. I'm going to plug it in here. I'm going to take all the twists out of this. Now again, I didn't mention it on this connector, but I'll mention it here. You want to make sure that you're in the ferrule closest to the latch. That's where the receive port is going to be looking for the signal. So I'll go ahead and I'll plug this in. When I plug it in, we're going to hear a chirp. So there's that chirp that we were talking about. We're going to go into loss length, pull up the menu, we're going to set our reference. So now the unit is basically zeroing itself out. It's finding out what the transmit power is here, transmit power is here, and that's our new 0. So now we're ready to do the test reference chord verification step. Again, from the normal LC, you'll notice that when we add the additional LC to LC chords in, however, we don't have to do that because we already have our additional fiber built into these patch cords. We just have to disconnect this cord here, and because I'm going to put it down, I'm going to put my dust cover on it. And then I'm going to disconnect the cord here. I'm going to put it into a coupler, and then I'm going to remove the dust cover here, plug it in, remove the dust cover here, and plug it in. Again, these connectors, both of these, you want the MDC to be upside down, or you want the triangle to be opposite the latch. That's how the receive ports are going to be looking for light moving forward. Now, because we're going direct from tester to tester, we want to create a flip. I personally like to always create my flip for the test reference chord verification step on the remote. So I'm going to pull the boot back, flip the connector over, and slide it forward again. I'm going to take my dust cover off, clean my fiber, plug it in, and I'm going to hear a chirp. So now we have to actually do a test reference chord verification step. So I'm going to hit test, and we're going to wait for our result. Now the tester is going to say pass for anything under about a dB. However, the technician has to be very careful, and they have to review the losses themselves. We want, for single mode, we want this loss to be less than 0.25 dB, and we'll see here that it's 2.2 and 2.1, so that's less than 0.25 dB. And if we were testing multi-mode, we would want these values to be less than 0.15 dB. Okay, so now we can see that we have a valid reference. Our test reference chords have been validated, so we're okay to go ahead and start. So now we're going to remove this. I remove this MDC here, put my dust cover on it. Now, if you're testing acclAIM, you have to take that polarity reversal out because acclAIM is a method C. So every 2 pairs is going to be flipped inside the trunk. So what we want to do is we want to go ahead and take the flip out of our patch cord. Now we can plug it into acclAIM, we can hit test, and we can be assured that we have the most accurate test results available. And finally, we're ready to test our cable plant. So here we have an example of an acclAIM trunk with our conversion adapters and MDC connectors on the front. We just go ahead, remove our dust cap, clean, go to fiber position number 1. Same thing on this side, remove our dust cap, clean, fiber position number 1. Now again, these are pairs. This is not fiber 1, it's position 1, so it's technically fibers 1 and 2. We heard the chirp, we're ready to test. We hit test. And we have our passing result. Again, very, very low losses. With the MDC connectors in the acclAIM solution, it's a very high performing system, very, very low loss. So now what we can do is we can go to our next fiber. We're going to remove it from here, clean it, plug it into position number 2. I'm going to remove it from this side, clean it, and plug it into position number 2 on this side. We're going to hear our chirp again. Normally I would have saved my passing result. However, I'm just going to go ahead for this one and hit test again. I'm not saving these. Very, very low loss, 0.24, 0.25. And again, you'd follow the same process for as many fibers as you have in your cable plant. Hope you found the video helpful. If you have any questions at all, please feel free to reach out to us at the information on the screen.